we have just discussed. Okay. So if I ask like materialized view, so materialized view fall under which category? It will be physical structure or logical structure?
Physical. Physical.
Physical.
I think
Materialized view,
logical structure.
logical structure. Materialized view, can you see the materialized view physically? No. So materialized view is logical structure of the database. What about PG underscore
Abhishek,
HB underscore config?
uh,
Yeah.
Abhishek, there's a one question. Can you explain MATLAB's view? It is a faster or something? What's the overall end-to-end of MATLAB's view in detail? Just 2 minutes about MATLAB's view.
So basically what happens, first of all, what is view?
It is a pointers to the tables. It already said.
Basically,
Hmm.
a logical view of seeing the data, right? Right? This is view. Using my view, I can see this much of data.
Mhm.
Okay. These all have data. But can my view can store the data underneath it when I
No.
run a view? No,
No, no.
I can't read it. I can't store it. So every time what I am doing technically, view going to table or tables and coming back and showing me the data. That's what happens, right? I'm seeing the data. But let me, but in some scenarios, this particular view gathering or particular process to gather the data for a view can be cumbersome or can be time taking. Okay.
Hmm.
And let's suppose every day morning, Monday morning, your CEO comes and he need a report. So technically what you did, you created a view.
Hmm.
Okay. So Monday morning from last 1 year, everything is going good. He comes to Monday morning, he's clicking one report and report data, everything is good. But what is happening side by side, this database where your views are running is going to be increasing. Okay. Or now what he says, boss, I'm seeing the data only related to this database ABC. Now I want to see the database of CDE and XYZ also. Okay.
Hmm.
So in that case, what you will do, you will going to add few more calculation or few more columns in your view, right?
Hmm.
Okay. Scenario one. Scenario two, this database was locally available in the server A, but CDE XYZ is not available in the current server. They are available in B node.
Hmm.
So what you will do, you can't use the normal view, right? It is not possible, right? To run
Hmm.
the view. It is possible. You can use database links. You can use
Hmm.
foreign data wrapper in the case of Postgre. But technically, again, it is going to fetch the data, but it will not store the data. In case if this view itself will store its data, my
Hmm.
overall processing time can be saved, right? Whatever I'm connecting to the foreign data or whatever I'm
Hmm.
fetching from my local database. To fix all these problems, a database engineer have created a view called materialized view,
Hmm.
which technically, first of all, it not only a view, it also creates a database underneath it in the form of table. So whenever you are creating a materialized view will also create its underneath table. And whatever view of the data that a materialized view is created for will be saved under this table. So overall execution is faster. Why? Because in traditional cases, when you hit metal view, it goes and collect the data. But here,
Hmm.
Materialize View has its own table where all these data view is already saved.
Hmm.
So what will happen? The moment you will hit this Materialize View, you will see the underneath table data. So that's why Materialize View is faster comparing with normal view. And you can do um, data cleansing, data massaging, data manipulation under the Materialize View. So that's why you create Materialize View. Okay.
So in case if the data is getting, I mean, if we use the materialized view
Mm-hmm.
at a certain point of time, for
Mm-hmm.
example, let us say at time
Mm-hmm.
A, okay. So after a few
Mm-hmm.
hours, if the new records comes, it
Mm-hmm.
segregates like with respect to time as well.
No, if you are creating a normal Materialize View with normal refresh, you will not see any latest delta. Let's suppose this is your source. Source now employee salary is updated to 20 rupees and Materialize View has still have employee salary equal to 1 rupees. Then if your refresh is manual, then you have to go and manually refresh your Materialize View. Then only this new salary will populate it to your Materialize View to
Okay.
20 rupees. If it is automatic refresh, auto refresh, then periodically whenever there is a change on the source, your Materialize View will also get refreshed. So again, in Materialize View refresh, we have complete refresh and fast refresh. So complete refresh will recreate this entire table. Fast refresh will just get the delta from your source. Okay.
Okay.
Materialize View concept may differ from Oracle to Postgre. So before committing anything, please read the documentation. Oracle Materialize Views are little different than Postgre Materialize View. Okay. Don't just compare them apple to apple. They are apple and orange kind of comparison. If you are implementing anything. Make sense, Rohit?
Yeah.
So
I
what
have
is
not
the
heard about I have not
Mhm,
about the Delta one. I
mhm,
have heard about the complete. I have to go for the refresh one. So I have
mhm,
to check it out about the Delta. You said that
mhm,
whenever anything happens at the
mhm,
source, it will be get transferred to the MATLAB view. So I have not heard
mhm,
about this.
mhm.
So I have to check it out. Okay.
Can someone give me a used case of Materialize View? Real time. Where do we use Materialize
Sometimes we can use it for the data lake purpose.
View? Mhm,
Like we can run, we can create a table according
mhm,
to the flattened data, right? Suppose
mhm,
we don't want all the columns, only few columns from multiple tables, then we can create a met materialized view and use it for that.
mhm. So, for example, I have a database called leave database where employees, whenever employee take leave, they are entering the data here. Let's suppose I have a thumb impression installed on my gate. Whenever employee comes to office, he gives the thumb impression. That data goes to here. Whenever employee is not giving thumb impression, I consider that day as a off. And this is my salary database where I'm giving the salary to my employees. My CEO want to understand uh, um, a kind of dashboard where he want to says see how many people took off on Monday or how many people took off the entire week, daily, weekly, monthly, and how many people are coming to office or not. Second thing, based on your attendance, I want to give you salary also. So what I will do, I will create a materialized view. My materialized view is remotely going to connect to this database, remotely connecting to this database, and I can clearly cut, create a view where I can say boss A person is worked only 28 days and he will get salary of 100 rupees. So these kind of implementation can be done using Materialize View. Make sense?
Yeah.
So mainly for reporting purpose for the queries which you are keep on running and have multiple data manipulation added or incorporated, materialized view is a good choice. Okay, but only thing you have to, the big headache that you have to handle is refresh. That you have to handle based on your materialized view configuration. Okay, let's go to the main topic again. Are we clear till here? Can I go ahead?
Yes.
Yes.
Okay.
Sir, one question.
Mhm.
Sir, it's not related to materialized view. It was related to views only. As you said, view is just a logical representation of a table. So, but it holds some temporary data. So, where does that temporary holding of data happens? Is it inside your RAM?
It is inside your RAM. Under the RAM, we have a
Cache.
we have a cache. And what is the cache name that happens on the session level? Session cache.
Section
Okay,
cache.
correct. Every
Okay.
session have its own cache. That's the next topic that we are going to talk about. A lot of things here. So that data is getting hold into your session cache, and this session cache is going to showing you the data. But the moment your session cache or your database level cache is flushed, your view is gone. Getting my
Okay.
point?
Okay.
That's why I was taking you through this route. I don't want you to understand the database architecture or anything in the traditional way where you don't understand what is disk buffer, what is swap, what is operating system lock, all those things. Otherwise, understanding all these things, how you will understand? Because I personally believe if you know the basic operating system level concepts of buffer and cache, then any understanding any database will be very easy. Okay. And I hope this session is going to give you a lot of benefit in that terms. Okay. Okay. Now, again, continuation to the old topic, we have to understand the Postgre architecture in two parts. Okay. One is process architecture and memory architecture. Okay. Process architecture and memory architecture. Okay. So what is process architecture? When I will say the process architecture, I am referring to this particular image. Okay, when I talk about process architecture, I am referring to this image. And whenever I am talking about the memory architecture, I'm going to refer to this particular picture. Okay, I want everyone to forget about all their previous concepts and everything, flush their mind for some time with me and understand all these things carefully so that from today onwards, you understand all these things in a very different point of view. Okay. So the process architecture is nothing but when we are talking about Postgre processes, Postgre memory area, little bit part of the memory area, and different segregation of your processes according to their day-to-day work or according to their work related to Postgre. Okay, so we are going to talk about in those areas specifically first. Okay, so the first thing, the moment you do system CTL start PostgreSQL, what is happening? The moment I say system CTL start Postgre, it is evoking a process called PGCTL. Okay. The moment the PGCTL is started, PGCTL will go and it will read your config file postgre.conf and postgre.auto.conf. Which file will be read first? Postgre, it's an interview question. Postgre.conf or postgre.auto.conf?
Auto.conf.
Very good. Why auto.conf? Why not Postgre?
Auto.com is dynamic file.
Auto.conf has the
Dynamic.
highest priority.
Mhm.
Is dynamic.
Yeah, someone was answering.
It has
So
the
this,
latest data, the
Mhm.
conf file.
Very good. It has the dynamic parameter change information is held by PostgreAuto.conf, and whenever system starts, it reads the changes first from auto.conf. Okay. So your PGCTL started, your config file has been read, and then what it will do, it will create a Postgre instance like this. Postgre instance will be created under your memory. Which memory? Dynamic memory, DRAM, or your memory which is attached with your server. Okay. Now, for time being, forget about other database knowledge, because it might be little confusing and it might be little different comparing with your older knowledge. Okay. Just think like you are reading a new database. Okay. Don't compare with any old databases. So the moment my database instance is created, instance has started, and instance has created my Postgre server process. So this particular Postgre server process, which we also call as a postman process.
Can you
So
zoom in, Abhishek,
mm,
because
mm,
the image is very
yeah,
big.
image. What I will do, I will move it, or I will delete it for now, and I will increase the.
Yeah.
Fine. So once your Postgres server process is started, it will spawn the next underneath processes. Okay, so process once your postmaster has started, it will start. Excuse me. Postgres server process is going to start all these different processes. So now the first thing that you have to understand is, let's suppose if your database is started, all these memory components, everything has been into the place, and a client is trying to connect to your database. The first thing that Postgre is going to start is your backend server process. Okay, so client process will go to the backend server process, and backend server process is going to communicate with your entire database components based on your client request. Okay. Hypothetically, just we are not going to go into many much internals and all, just basic understanding of all these things. So backend process, every client has its own backend process. Okay. Now the people who are coming from the Oracle or MySQL background, they must be thinking, in our side of the databases, we have PGA, right? In Oracle, we have PGA, right? PGA and listener process and all those things, right? So here also you can think like your backend process is behaving like your listener process, okay? Which is listening the client request and it is communicating with the entire Postgre database instance, okay? And also your backend server process is interacting with your different memory areas. The first memory area that we should understand is shared memory area, okay? Which we will talk about in the another part of our understanding, where we are going to talk about the memory area. We are just talking about the processes now here, okay? So this one I'll talk in that section, but now after your backend process has started, every backend process has its own work, defined work, okay? So the first one is background writer, okay? So what is background writer? The background writer is a process which basically takes the blocks which is dirty or which is committed from your shared buffer area, and it is writing to your data files. Okay, so background writer is gradually taking the blocks from your shared memory based on the different condition that we are going to talk about, like commit, checkpointing, all those things happens, and this will take the blocks and it will go and it will write to your database data files permanently, so that whenever database is restarting or database is crashed, so user should not lose the data. Checkpointing process. First of all, what do you mean by checkpointing? Why do we use checkpoint? Anyone?
Sir, it is
To
for
maintain
flushing the.
consistencies.
Okay.
Sorry.
Can we explain
Updating the
what is
header
the
of data file.
okay, updating the header of the data file, which is again the consistency. So anyone else?
Flushing the data from shared memory to disk.
Very
Correct.
good. Very correct answer. Flushing the data from shared memory to disk. And on which particular okay, let's not go now. We'll go all these concept in performance tuning. Okay, so if in high level, what is the core purposes of checkpoint?
In Oracle, it keeps the content of the online redo logs consistent with the data file.
Very good. In Oracle, Redulog files are getting checked out, and every data file headers are updated so that we are consistent in the database terms. Consistency. Another thing which is related to checkpoint, consistency. Why do we need consistency? What is the whole purpose of consistency?
So in a case of crash, right?
Service state.
Database
Very good.
crashes, we need to have a pointer wherein we can recover the data from that point of time.
Very good answer. That's what I was expecting. So consistency is indirectly, invariably, very related to your crash recovery or recovery. So in the time of crash, in the time of failure, in the time of disaster, there should be a point. Till the point I would say everything was working fine. I was consistent. So please revert me back till that particular point. Okay. So it is nothing but checkpointing. So in the Postgre, we have similar kind of concept called checkpointing. So in the checkpointing, what happens? Your database is getting checked again and again by this particular process. Is that clear, everyone? Just high level. I don't want you to go to very depth. Just basic understanding. Is that clear at least? Background writer, checkpoint. Are we clear at least?
Yes, I have a question. So you said the client when it requests to the backend process, right?
Whenever client connects to the Postgre database, automatically a backend process is getting created. This backend process is nothing but OS level process, which is communicating between client and Postgre database server.
So my question is that if I have hundreds of clients connecting to the Postgre, so we have hundred of backend processes,
100
right?
of backend. Yeah, that is the another drawback of the Postgre. Yes, that's a fair statement.
And it is not reusable, right?
It
The
is
backend process.
backend process is not reusable. It is only
Okay.
dedicated process. You can't reuse it. So that's why there is a famous article available on the internet called "Why Uber Has Stopped Using Postgres." Very famous article. From last many years, this is going. So you can say, in other words, why this is one of the drawback, that whenever you are creating a new connection, Postgre is going to create a dedicated process for that particular client. You can practically see that also. So mean to say, if I have 100 of clients, I'm going to see these kind of process 100 times on my database server. What is the remedy of this? I should not ask this question now, but at least we are discussing.
Implement connection puller.
Very good.
Connection pool.
Connection pool. So connection pooling is the concept where we can reduce all these kind of things. let me not
But,
confuse you.
Uh,
Yeah,
But Abhishek, connection pool is on the DB side, right? It is not on the OS. These are the OS processes, right?
these are the OS processes, but it is controlled by Postgre. It is created on
Okay.
OS, but controlled by Postgre. And also it is getting created because you are getting a connectivity request from your client, right? The moment I connect to Postgre, by default backend processes started. Okay.
So
And
you mean to say the connection pooling will have this backend processes which can be reused.
which can be reused and
Okay.
which can be reused, but again, there will be certain kind of rule involved in that. Okay. When we come to the connection pooling, normally DBA doesn't understand the connection pooling in a, they just think like connection is just a connection. Okay. But we are not going to talk like that. We are going to talk. What happened to my pen? So we are not going to talk like that. We are going to talk in a way where we will go and do the postmortem of the connections. We are going to do the postmortem of the connection and we will understand what kind of segregation is there under the connection. So mean to say it is a statement based connection, session based connection, or command based connection. Then only we can do further investigation which kind of connection pooling is more suitable for the case. Getting my point? And how it is going to behave on my databases, right? So all these things we are going to talk about when we will talk about the connection pooling. Let's go back to our topic. Is this clear, everyone? Everyone? All these things are clear? Whatever we have talked about so far? Raj, you got your answer or you want the further discussion? Like, are you clear?
Yeah, I got.
Yes.
Yeah, I got that.
Okay. Checkpoint clear or any more discussion? Because I want you to be very, very clear about this. The more you understand the architecture, the more you can do performance tuning, the more you can attend the interview questions, or the more you can do your day-to-day things perfectly, properly. Is this
Abhishek,
clear?
can you please explain a bit? I mean, one more time. I didn't understand.
Okay. So whenever a client is trying to connect to a Postgre database, first of all, you are from which database side? DB2, right?
DB2. Yeah.
Okay. So in DB2, what happens when you connect to a DB2 instance? What happens? Like
The background, I mean, the listener will listen it, and
mhm.
agents will collect the data, and it will pass that to other sub agents, and
Sub-agents.
one will be the coordination agent, and all other will start the, I mean, collecting the data and
Very
the
good.
coordination. Yeah.
In the same way, when you are just opening your client process, client can be anything. Let's suppose dbeaver tool or any driver, database driver or something, which is connecting to your database, or a normal user who is running the query select star from employee. The moment this client process is established, the client process is going to the moment he is going to communicate with the Postgre server, it will create its own background process, which is Postgre backend process. Okay. Under the Postgre backend process, this is going to be a gateway between client and Postgre server for a client. Here only, first of all, its backend process will be created. And this backend process is going to communicate with the Postgre database server or the instance behalf of the client. Okay. And this backend process, we are going to understand more this backend process in the further slides or further topic. But currently just think like the backend process is established and it is talking to your database behalf of the user request. Let's suppose tomorrow more clients are connecting to my database. Let's suppose today this is the first one. If let's suppose 100 users are connecting to my Postgre database, then I will see 100 of backend processes spanned under the Postgre database. in very high level. Is this clear at least?
Yes.
Okay. Check pointer, auto vacuum. So in Postgre, things are little different in terms of bloating, in terms of recollecting the unused data blocks to reclaim the unused data block or the row migrated or row chained blocks. I think the people who are from the Oracle, they must be knowing a concept called row migration and row chaining, right? Where your row is getting migrated, row is getting chained. In MySQL, people must be knowing about the bloating of blocks or bloating of the table. Okay, so to remove all the bloating or to remove unused the block which is currently unused by the table, we run auto vacuum process. We have a dedicated topic for auto vacuuming and auto vacuuming tuning and everything. So we'll talk about that in that. But currently just think like as a process, mandatory process, which is started and which is needed whenever we are running the auto vacuum process. Okay. Wall writer. What do you mean by wall writer? First of all, yeah.
Sorry to interrupt you, Abhishek.
Yeah.
Like auto
Can you speak a bit
vacuum
loud?
will, yeah, auto vacuum will remove the dead tuples.
Correct.
So, but which is not equal to rows chaining and row migration, right? It's equal to like multi-version concurrency, right? So like
Multiverse
whatever the,
concurrency,
yeah, which
but
is equal to undo and redo.
undo and no, it is not undo and redo. It is not at all related. It is related with MVCC. It is related undo and redo, but not completely unrelated with your row migration and row chaining, because that is the core concept. Your bloating comes into your database, correct? In Oracle, we have that concept, right?
Yeah, row chaining, row migration, like when the particular data is not sufficient in the particular block, which will extend for the another row.
Another
That is
one,
called the row
correct,
chaining. So row
correct,
migration, where we have the block is not fit into the particular place, it's combined of the multiple blocks.
correct,
So yeah, but when come to the data pulse, when particular data, there is a image of data which you are going to be update, which you are updating, then the particular record is going to be saved for the some purpose. So
correct.
that is the, that's right. So but how can I understand here row migration equal to data pulse? That's my
No,
intention.
mean to say not 100% equally, but from the
Mm-hmm.
conceptually, the bloating, how the bloating happens on your tables, right?
Okay, okay.
The bloating point of view in Oracle, you have row migration, row chaining, right? That's what you understand, right? In the same
Mm-hmm.
way, in Postgre, first of all, auto vacuum is related to your multi-version concurrency control concept, right? So
Right.
where a user should see the concurrent image of the data. So in a table also, we are basically creating a tuple, the temporary tuple to see the data so that the other user is not seeing the other side of the transaction. Let's suppose two transactions are running. So from that point of view, I'm trying to tell you this, just make a reference point that how
Got it.
to remove the bloating in the Oracle, but how same thing happens in the Postgre. But the concept is not completely same, but just to set a reference point, you can think like that. That's what I'm trying to tell you.
Got it,
But
Abhishek. Thank you.
there is an interview question again.
Mm-hmm.
How we manage auto vacuum in Postgre, and same thing how it happens on the Oracle or MySQL. Just read
We
about it.
can, yeah, we can set as like we can set the parameters. We have to be tuned for our own way, like auto vacuum is with the threshold value or ideal
Mhm,
sleep time. So
mhm.
which will help us to manage the auto vacuum in the PostgreSQL.
Yes, I have a dedicated section for auto vacuuming because it's a very
Mm,
important concept for the database
tuning
administrator.
section.
So we are going to talk about that. But there's a small there is a important question that sometimes people ask. In Postgre, you have auto vacuum, right? Where we
Mm,
are showing the old value and new value to a transaction. But similar thing how it happens on MySQL and Oracle. So just read about it so that you will
sure.
understand about these questions also. Okay. Wall writer. Wall writer, what is this wall writer? First of all, what is wall?
Transaction log.
So kind of, you
Right
can
ahead
say
log.
it's correct, right ahead log. So let's understand the wall first. Right ahead log. What do you mean by right ahead log? What is wall? Why it called as a right ahead log?
It
Before
means
applying to the desk, it returns the wall.
Very good. So let's suppose there is a table and table have 3 column A, B, C, and table have some data, 10 rupees, 10 rupees and 10 rupees like that. Okay. So let's suppose there is a user who has connected to the database table and it is changing the row. Let's suppose currently the A record was 10 rupees and he is making the 10 rupees to 11 rupees, means 10 plus 1. So technically what is happening here? In the database world, these kind of things, what we call it?
We are updating the row basically.
Updating the row. And updating the row is again called as a
DML.
DML. What is DML? Data manipulation language. Wherever we are updating anything, we call it a DML. So let's suppose a DML operation is happening. So whenever you are changing a value to the existing database, the Postgre database is storing the change detailed information into a log, right? First of all, it is not going into the log. It will save into a buffer area. Okay. And what is that buffer area? Which is wall buffer. Right ahead log buffer. So whatever change information was getting changed, get recorded into wall buffer. In a form of what? In a form of what? In a form of
Pages.
pages. Pages is nothing but your block. So this particular block in Oracle's word, you can call it what?
Block.
Dirty buffer, right?
yeah, dirty buffer.
So whatever data is getting changes or whatever the data has been changed will get captured into wall buffer. And periodically this buffer will go and saved into your log files. Okay. So this particular memory, this particular process is responsible to write the block from your wall buffer to your log file, wall file. So that's why we have created a mandatory process called wall writer. And this wall writer is responsible for writing the wall changes from wall buffer to wall, where wall data or wall files. Okay.
Abhishek,
Mhm.
is it what is being changed that is right, that is going to be written there, or the before image of the data?
Correct. Very fair to say that it is a uh, uh, right before image of the data, which is actually when a session is doing commit. So before doing a commit, let's suppose he issued a commit, wall process is going to capture the change information, and it will put it inside the wall buffer, and wall writer is going to write that particular buffer to the data file or pages to the data file. It's like that.
So
Is this
Abhishek,
clear? Mhm.
Can we compare this with binary logs in MySQL?
Binary log with the MySQL, very good. You can say binary log with the MySQL whenever there is a change happens in MySQL or InnoDB buffer pool, your changes goes to your binary log. Okay, but there is a catch, small catch or a small thing. Binary logging by default is not enabled in Postgre. which we called as a archiving. Okay. So archiver is not at all by default enabled in the Postgre. Same thing happens with the Oracle also, right? In Oracle, archiving is not enabled, right? We enable the archiving whenever we need to do it, right? So same thing happens here also. Stats collector or any question before that in that sense. Any question, anything is coming your mind, feel free to discuss about that. Otherwise,
So
whole Mhm.
archive you said that is not enabled in Postgres or Oracle.
By default,
So
by default.
what I understand the definition of archive is that we are archiving the data of the tables, right? In
Correct.
MySQL terms, I'm telling you.
Mhm.
But
No,
what
no,
is
no,
the
no. Okay, no problem. You carry on your question. I will just explain it later. Okay.
yeah. So I wanted to understand what is the
Mhm.
actual meaning of archiving in the sense of
Mm,
Postgres
mm,
or
mm,
we're studying Postgres. So what is the
mm.
actual meaning of archiving in Postgres?
Okay, okay. And you are relating this with MySQL, correct?
Yeah.
You are a MySQL DB, right? Okay.
Yes.
Let me tell you two things that you should not mix with. The first thing is, if you are coming from the MySQL background, don't mix with this MySQL archive engine. Let me 1 minute. Let me change my this one. First thing, if you are coming from a MySQL background, don't consider this with the archiving engine. No, it is not related with that. Archiving engine is a complete different concept where we are archiving the data or archive related information in the engine format, like InnoDB, MySML, all those things. So it is not at all related with that. It is related with a concept where your change information, like your MySQL bin logs. So bin logs are equal to Oracle's archive log and also Postgres wall logs.
Okay.
So bin log is nothing but whenever a data is getting changed, let's suppose employee salary was 1 rupee, I have added 1 more rupee. So what will happen? Data is getting changed, right? So that log
Yeah.
will get generated, right? In the same concept, in Oracle, we have archive logs. Postgre, we have wall logs. In Mongo, the people who are from the Mongo, you can say it's a, in Mongo, what we call
Upload.
it?
Oplog.
Oplog. People who are from the Elastic, they can also call it log. Okay, so it is oplog basically. So it's related to that concept, not at all related with engine and all. Another concept, it's not related with the archiving kind of concept where you have main database and after certain a time your database is getting archived into multiple databases. People who are from the data engineering point of view or people from the data science point of view, I'm not at all talking about this. This is not the concept that I'm talking about. This is altogether a different concept. Archiving is simple means a data is getting changed and the change information is getting stored into small logs periodically. That's what I'm talking about currently. So don't interrelate with all these concepts. That's what the concept which I have mentioned. I'm not talking about the archive engine, archiving, data pipelining, archiving. No, it's not related to that. Plain database concept. Data is getting changed and it is getting converted into change information. That change information goes to a simple binary file or simple text file. That's all. Makes sense? If you want to understand all these concepts, I can explain you, but not now. But that is not related with that. Make sense, everyone? Is that clear? Am I audible? Hello?
Yes.
Yeah.
Okay. Statistics collector. What do you mean by statistics in the database? What is the statistics?
Like tables having which tables are having indexes, primary key, foreign keys, table having triggers. So these are the statistics plus also the performance related statistics, like which table is taking how much of RAM, or queries which are taking doing using temporary tables. These are the statistics.
Very good. So basically, gathering information about metadata of database or gathering the information about the data is nothing but statistics collection. And these statistics collections are important to run the database operation. The first important concept comes, which is related to the statistics, is query planning. Okay, the more your statistics are updated, the more your optimizer will write, or optimizer will execute the SQL properly. Okay, so statistics are nothing but the information about your data, how many indexes we have, how many rows we are having in the table, what kind of table we have, what kind of column we have, all those things. Okay, so it's like that. So basically we have a process called stats collector, which runs automatically. There are certain configuration. It runs on some timeout value. There are certain configuration parameters available. Using that we can control it, or we can run it manually also. Okay, so we will talk about in detail in the performance tuning section. And also when we are talking about the query tuning part, we will talk about the stats collector. But for now, think like it's a process which periodically runs, and it gathers the information and it updates the catalog tables of Postgre. Okay, one more thing I want to add here. Whenever I say catalog table, or catalog, basically I'm referring to these following things. People who are from the Oracle side can think like I'm talking about $V database or DBA underscore data underscore views or dictionary. People from MySQL can think like I'm talking about performance schema, MySQL schema, or there's another schema in MySQL. I forgot about that. Performance
Information
schema,
schema.
information schema. Mongo people can think like I'm talking about admin database, admin collections, the collections which is technically holding the information about my database, like White Tiger storage engine or the default engine. People from Elastic can think like it's a basic Elastic database. That's all. So what is catalog here? The catalog tables are the table which is holding the information about your database cluster. Let's suppose if I want to see the Oracle in Oracle, if I want to see the user, what query I run? I run select username from $V users, right? Or DB underscore users, something like that, right? In MySQL, we run like select MySQL, select user, then host from MySQL dot user, right? Something like that. In Mongo, we just do show users, right? Something like that. So basically these informations are coming from where? These informations are coming from your base tables. Base tables are nothing but the catalog table which stores the information about your data, excuse me, database or database cluster. So whenever I refer to the catalog, I'm referring to a table which is holding the information about my cluster. Is it clear? Catalog table, at least some high level.
Yes.
So we are going to talk about the catalog tables in detail in the further section, where I'm going to give you some day-to-day catalog tables that you can query and you can get the details. Log collector. What is log collector? Log collectors are the process which is basically whenever you have anything happens on your database and it is getting converted into the logs, that logs go, the log writer, basically what it does, it writes that particular log to your Postgre log files. Okay, Postgre log file is equivalent to your MySQL error file, MySQL journal log, MySQL normal var log files. For the Oracle people, my log file is equivalent to my alert log file. Mongo people, Mongo log file. Okay, Elastic people, Elastic, or like the people from ClickHouse or TIDB, you can think like your normal exceptional log. Okay, makes sense? Is it clear? At least log file, normal logging file. Whenever you are creating normal logs, this particular process is writing to the log file. I have a dedicated session on logging because Postgre, like Oracle, Postgre is not that mature to provide you the log. So I will teach you how you can tune your logging method so that you can capture more logging information in your Postgre logs. Okay. So we are going to talk about all those concepts also in the further session. Archiver. So archiver is a process when you are enabling the archive log, or whenever you are starting the archive log process, mean to say, normally your archiver process is not started. The moment you start your archive log process, your wall is getting written into your wall logs file. Okay. So basically wall log files are are nothing but your archive log files in Oracle, or in MySQL, they are related to your bin log files. So that process starts. So I'll show you that also, how you can keep your database in archive log mode. All those things we are going to discuss. But at least are we clear with this? The common architecture. So what is this architecture? What we call it? Which part of the architecture we are in?
Logical
Physical
architecture.
architecture. Physical.
Physical.
No, this is process architecture.
Process architecture.
There are another architecture, another thing which is available in the Postgre, which we call it as a memory architecture. Okay. So what is the time now? Okay, 1. Can we close the session? We'll talk about it tomorrow because it is too much load on your mind to digest this knowledge. I don't want you to understand the architecture with the typical way, just go and read the architecture, come back and all. No, no. We have to interrelate all these knowledges and then think from that view that this is my Postgre architecture. Otherwise, it will be very, very difficult for a human being to understand the entire working workflow of my Postgre. But do you think this is the right way? Will you understand more the way I'm teaching you?
Yes, very correct.
Okay. So in case if you have any question, any small, big, silly, anything, please note it down and come back to me. We can have a detailed discussion, but this is one of the important session or one of the important part of my training. Don't take it easily. Don't just believe on my words. Ask question as much as you can. Even I am fine with the arguments. I have very heated arguments also with the people in my past classes. I'm very much fine with that. They must be having some different understanding. I must be having some different understanding. Let's have come to the table and let's have a long discussions about that. But end of the story goal is you should be able to understand all these things. Sometimes if you go to the interviews, they ask all these kind of information. Okay, that's why I'm teaching you in this way so that you understand all these things one by one, and later on we can connect all the dots and we can create a complete Postgre database architecture. Make sense, everyone? Everyone is good?
Yes.
Yes.
If someone is not clear or have further doubt, I can wait here. We can have more discussion on that. Okay. Related to the assignment, how many of you have completed the? Prasant, you are about to say something.
No, I'm
How many of you have completed the assignment, the last assignment, Jenkins one? That is also very
Abhishek,
important.
I will complete it by tomorrow.
Okay,
Yeah.
it's not like school or something. It's not like homework, but sometimes I emphasize on things which is important. Okay, So try to create a pipeline using Jenkins and create a virtual machine. Once your example one is implemented, try to create a pipeline where you are passing the virtual machine parameters like CPU, how many CPUs you need, what will be the memory size, and what is the OS. Create a pipeline like that. If you are not able to do, please let me know. I will spare some time and I will show you practically how to create it. But please try to do that. Okay. It is very important.
So the question is, you need to, so do we need to create the RDS or we need to create it in the Vagrant?
In the Vagrant, but let's
Okay.
not complicate it. Let's do it in Vagrant. So simple ask is, you will go to the job, Jenkins job. The moment you will run it, you will say run with the parameter or something, build with the parameter. It should pop up you with some kind of input value, how much your VM CPU is going to be, how much memory you want to give. And further, if you want to complicate it, add OS also. I'm fine. This OS is optional. If you want to create OS, you can create, otherwise you can leave it, but at least memory and CPU, it should ask. Why I'm not asking about disk, because disk is a plugin method. Sometimes it might fail. So, but let's do it with CPU and memory. Is this clear? The assignment?
Yes.
Yes.
Okay. So if everyone is clear, we can close the class.
So no need to create any Postgres database. We need to just provision a VM with the CPU and memory in Vagrant. Is that correct?
In Vagrant, if you want further complication, add the Postgre installation also in that.
Okay.
Why I'm telling you, in case if you are doing this practice again and again, you are creating multiple VMs and all. So once your pipeline is ready, so no need to do it again, right? You just go to your Jenkins, run it, and your machine will be ready. So your further
So
lab work will be very easy.
this machine we can use for any, database like Postgres,
Anything,
Redis, MongoDB.
Redis, MongoDB, anything. Even further, you can automate like this single Jenkins job. The moment this job will run, it will create MongoDB 3 node with primary and secondary replica set. MongoDB job with master MySQL, slave MySQL. So master slave architecture also you can build. Single script.
So what is the OS that we can choose from Alma, or is it?
What I'm suggesting you, always choose the OS which is I have talked about it in my I think first class or second class. I don't know if you people were there or not. So in the market, majority of the servers are running on Windows. I don't consider it now. I'm more focused on the Linux part. So if you can do it on RHEL or Alma is going to be better, because what I can see gradually Alma Linux is taking over to Red Hat slowly. This
Got
data
it.
might be little slow, but that's what I can see, because Alma is faster than Red Hat. So try to do it on Alma Linux, or if you want, you can also use Rocky Linux.
So I could see the Vagrant has some general purpose RHEL 9.3 or 9.4 something. I can use that, right?
You can use that. You can use that also. You can go to Vagrant Cloud and you can choose that also. It's up to you.
Okay.
Here you can get all the details, like which RHEL you want to use.
So
Okay.
actually, when we are building the Vagrant image, actually what it does, it pulls from this Vagrant cloud and build the things, or it already stores the things in the local and it provision the things. What
We have,
happens?
yeah, I'll explain you. You understood the concept of Docker? We
Yeah,
had a discussion, right?
yeah,
So what happens in the Docker? We pull the image, right?
yeah,
From Docker Hub to our system.
yeah,
right? Like this.
yeah.
Same thing happens when you run the Vagrant file. It goes to the Vagrant cloud and it brings that particular image based on your provider.
Okay.
Let's suppose you are choosing the provider as a VMware desktop. It will go and it will bring this particular image into your machine and it will unextract it and make as a virtual machine.
Okay.
The only good thing about it is like when you install any operating system, you are installing with basically the workflow method where you are installing a lot of unwanted things, junk, right? And this particular images are lightweight, compatible, generic images. Okay. Generic image is nothing but you are just buying a mobile phone, Android phone without installing any app or something like that.
So without GUI, that you mean to say?
Without GUI, yes.
Yeah, got it.
Base image, but you have option to enable the GUI also. If you want, I will give you the command. Just integrate in your Vagrant and it will give you a fully functional GUI version also.
Okay.
But GUI build
that
is
is
going to
not,
take long time. Yeah.
Yeah, that is not the company doesn't use that.
No,
right?
no, they are not using. They are not using. It's same like EC2. You're
Yeah.
building a EC2 without GUI.
Got it.
But some AI and ML related programs we install GUI also.
Okay.
That I'll tell you later. Make sense, everyone? Clear? Good. Dhirinder, your job is done, right? That mock data you are populated, right?
Yes, 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 yes.
It worked, right?
Yes.